we need to talk about running Pocket in production, mostly due to the fact that in our clean room testing, we've done three types of load testing. We've done validator load testing, which stress tests how many validators can be in the consensus process. As you guys know, we use Tendermint with a slight modification that we did. We did relay load testing in order to assess that Pocket adds as little overhead as possible on every request. And we also did a block producer test that ensures that block production is weighted based on the amount that nodes have staked and so on. So in the result of all of that, plus the, as Michael mentioned, accelerated the development, I talked to him about putting together something with our close infrastructure partners, so they get firsthand knowledge about what it's gonna mean running Pocket in production. So without further ado, I wanna just get into it. The first thing I wanna do is give everyone a refresher, the appropriate refresher that is gonna be in all of our presentations about how the network works. I'm not gonna dwell too much into this high-level overview, as we will be zooming in multiple sections of this architecture. So it all starts with an application that installs one of our SDKs, and they will produce a build that they're gonna distribute to their clients. These applications are standalone from the network in a node side perspective because they are not nodes. The way these applications get connected is because the SDKs or even the application developer themselves will include a pre-existing list of dispatch nodes. These dispatch nodes function very well, much like the bootstrap nodes that are in every other blockchain, where you need an initial node to tell you who the peers are and who to connect to. And sorry, and that's what we call the dispatch process. So any Pocket node is able, regardless of it being staked or not, is able to serve this dispatch information via our dispatch endpoint. And application clients will be able to do so. What these sessions will contain is a list of 5 nodes that will be servicing that application for data during a finite amount of time, which is a session. For mainnet, we have determined that the best course of action is to have 1-hour sessions. Sessions cannot be too long or too short because of security considerations and performance considerations. So we consider 1 hour to be the sweet spot. So what's going to end up happening is that after these clients know who their nodes are, these nodes now will be added automatically to the dispatch list. So whatever the application had inputted as pre-existing dispatch nodes, every node that is a servicer will be considered a potential dispatcher and will be added to that list. This list will be rotated, and it's going to be kept in application cache. So what's going to end up happening is that these nodes that are paired with these applications are going to serve any blockchain that the application requested for, even in an even manner. Meaning, if the application requested 1 million relays, each node is going to serve 200,000, up to 200,000 relays during that hour. The relay cap is established in a per session manner. So after that, clients are going to be able to request data from Ethereum, POA, Tesos, etc. And they'll be able to fulfill their functionalities using that data. That's in a nutshell 500,000 feet from above overview of the problem. So understanding a little bit of the network topology. Pocket network will have 3 basic archetypes of nodes given these explanation that I just went over. The first type is going to be the full node. A full node, as in any other blockchain, is going to be a node that is going to sync the blockchain and propagate transactions to their peers. This is the most basic type of node, and it's something that is very common in any blockchain's architecture. Then you will have the seed nodes, which is another word for bootstrap node, which very similarly to how dispatchers show the application who are their nodes, the seeds are the ones that show nodes who are the other nodes in the network. Without these seed nodes, nodes will be isolated and they wouldn't be able to form connections between each other, which is why in this diagram I've chosen to represent them in the middle. Both full nodes and service dispatch nodes are gonna connect to seeds first, get peers, and then form their own connection. So in a fully mature Pocket network, even if the seed nodes go offline, the address books of all the other nodes should be filled. So in that way, as long as those address books are not white, they should be able to connect to one another. But as you can see, these seed nodes, especially during Bootstrap, are gonna be an essential part of the network. And then you have the service dispatch nodes, which are basically have all the functionality of the full nodes, meaning they sync the blockchain and they're able to propagate transactions. But they are also authorized by the protocol to service requests, which is why these ones require an account that is staked into the network as a node. So to finish with the overview explanation, I want to go over very briefly about the Pocket Core's architecture. Pocket Core is mainly a three-layer application. The first topmost layer, which those of you who have interacted in testnet have noticed, is the Pocket Core application per se. This application contains all the user interfaces, the RPC, the CLI, and the config modules that on top of all the main business logic that needs to happen to enforce the protocol. Below that, as a main direct dependency, there's POS. POS is our fork or replacement of the Cosmos SDK, because Cosmos SDK is very opinionated in some aspects, and that what we were spending more time trying to figure out our business logic, our main value proposition, than fighting Cosmos. So we decided to just fork it and include here all the commonalities that are included in Cosmos SDK, but geared towards the needs that we were trying to enforce. And then here we have a Tendermint fork. This Tendermint fork is not a replacement like POS Mint is for Cosmos. It's exactly the same as Tendermint with one difference. We've decided that because we're going for a pure POS architecture and not a delegated POS architecture, we couldn't have a round-robin algorithm determine who the validators are going to be, because that's going to expose. Round-robin allows you to determine in 100% of the cases who the validators, who the next block producers are going to be in the future. So for our architecture, we wanted to avoid that, and we reutilized our pseudo-random weighted selection algorithm that we use to select nodes for sessions. And that way, the only node that is going to be known in advance is going to be the next block producer. So until the next block is not finished, an attacker wouldn't know who of the thousands of nodes that are probably going to comprise the Pocket network in the future, who's going to be the next block producer, making it more difficult to stage and plan and coordinate an attack against the block producer. I want to end this slide as an overview of what Pocket is and how Pocket is constructed. Does anyone have any questions? If I'm going too fast, complaints
Yeah.
are also valid.
I have a question about the seed nodes. The seed nodes are only nodes that are owned by Pocket, right?
No, not necessarily, and that's a very great question. We will prefer to allow anyone to run a seed node. Of course, it's up to us as client developers to include the default seed nodes that most people are going to use. So the more decentralized and distributed the selection of seed nodes is, the more resilient the network is going to be. So even though any node can choose who to seed from, we would like to present the community with as many seed nodes owned by as many entities as possible.
And it would be possible for an application to run their own seed node rather than relying on the ones you provide, right?
When you mean application, you mean like an application in terms of Pocket Network?
Sorry, the team that runs an application could run a seed node to tell their application how to connect, right?
No, they will need to run a dispatch node. It's not the same thing. A dispatch node is for applications. A seed node is for other nodes in the Pocket Network.
Okay.
Mm-hmm. But that is entirely true. An application could choose to run their own dispatch node, which is just a full node, totally synced to the network. And then their clients, all they have to do is a single request to their trusted dispatch node. And then they could choose not to use any other dispatch nodes.
Right. Yes. Sorry, I guess what I meant by that is, yeah, they can use their trusted dispatcher rather than using one of the public seed nodes.
Correct. That is completely correct. But in our sorry for interrupting, but just to top it off, in our architecture, we wanted to relieve the application from running any infrastructure, which is why we pushed we made it possible to push all the burden into the network. But yes, it's modular enough, so if the application decides to run their own dispatchers to avoid having to trust someone else's, they can do that.
Okay,
sorry, who did I interrupt?
To finish on the seed node, that means that you'll maintain a public list of community node.
That is correct.
Seed node. Okay.
That is correct. Like in our client, we will prefer, even for mainnet, like for example, if any of you are able to run a seed node, we will prefer to have them all in the default list. So when people just install the client and run start, they're gonna connect to one of these seed nodes and they're gonna sync their peer list from there. That way we can ensure the highest degree of service, but they can choose to connect to their own seed nodes if they want.
Okay, and last question, when I run a node, does it contain the seed service?
Mm-hmm.
Yeah.
I'm sorry, what?
When I run a service dispatch node, does it contain the seed service?
It does contain it. It's the same software. It's all the same software. But because of how Tendermint is designed and implemented, and I was going to touch on that in a future slide, but because of how Tendermint is designed and implemented, we cannot have a state node, meaning a service node, be a seed node at the same time. They have to be separate identities. So because of that, it will have to be its own node, its own setup. So thank you for the question, guys. Does anyone else has any questions before we proceed to the next section? Cool, silence is the sound of victory. The next section, I'm calling it running Pocket Core. I'm gonna go into details on how we recommend a Pocket to be run. However, we've always, and this is a core value of our engineering organization, we've always wanted to make Pocket Core to be as modular and unopinionated as possible. which should allow you a flexibility in how you want to run your infrastructure. Because I know each one of, and every one of your organizations have their own methodologies, their own skill sets, their own technologies that you prefer to do DevOps, to do infrastructure management, analytics, etc. So in order to avoid putting all of you into a single, like amorphous mass of node runners, we wanted to give you as many options as possible. However, we do recommend you follow these guidelines with whatever technologies are compatible, so you can make the most out of your Pocket operation. So the first thing I want to touch on is the environment. There are 4 key pieces of the Pocket of the environment that need to happen to run a Pocket core. The first thing we recommend is using a reverse proxy. Anyone who's run a web scale application in production knows that reverse proxies are the most battle tested way to handle external connections that are exposed to the internet, to the open internet. And we recommend the reverse proxy for 2 reasons. We didn't include any SSL termination module in Pocket Core because it was to our understanding that if people run it with a reverse proxy, it's going to be a way more battle tested implementation to do the SSL termination that way, rather than using us trying to re-implement the wheel and provide some sort of SSL termination within the client itself. And then request management. And I'm gonna touch on in a section about the scalability, about why is it important to have some sort of request management in the when using Pocket Core. Because Pocket Core is going to be open, and it's going to be, and applications can join with different throughput requirements. And because a node can service requests from multiple applications at the same time, request management is going to be key to keeping your setup stable. The second portion is going to be networking. And networking is subdivided into 2 parts. The first part is which ports need to be exposed to the internet. And those are the Pocket RPC fault, which defaults to the port 8081, and the Tendermint peer-to-peer port, which defaults to 26656. So those of you who have participated in testnet will know that we also have a third port, which is the 26657. That port is the Tendermint RPC port, and for testnet, we deemed it not that, we deemed it more useful than insecure, and we let people run it open. But in production, it's not advisable. Use that port for your own consumption in case you need to get some metrics or some information that is exposed via that port, like the status, consensus state. There's a few, and I recommend, if you want, to go into the Tendermint documentation and read all the available endpoints that you can have there. But none of those are required for you to use in order to run Pocket. Everything is abstracted in the Pocket application, and the Pocket application uses that to connect. The second part about the networking, it's the when you're running a service dispatch node, one of your options is to have it share a private network with your other blockchain nodes. But so all of you are already running blockchain infrastructure. So if you're gonna if you don't want to expose, you don't have to expose those blockchain nodes to the internet in order to use Pocket. Pocket will act as an interface between the internet and your node, so you don't have to expose those nodes in any public matter. You can just create a private network with them, and Pocket is going to connect via HTTP as long as you have the firewall rules and the networking rules that you need to have both boxes be connected. If you're using containers, then whatever network configuration your containers are using to connect to one another. Do keep in mind that if you use this choice, those other blockchain nodes, let's say Ethereum or Tezos or whichever, are still going to have to connect to the internet via their peer-to-peer ports in order to connect to the respective networks. Pocket doesn't touch that part at all. Pocket only talks to the node via the RPC port. So the last part is process management. As with any web scale production application, Pocket Core should be run using a process manager such as systemd or any other in order to handle restarts or any process level configurations in how you want to run the process itself. I think before we move on, this was a lot of information. Anyone has any questions? Oh, perfect, awesome. So I'm gonna break down each type of node that you saw in the diagram in the beginning more deeply, so you can see our recommendations in terms of how you can go ahead and configure these nodes. The first one is the service dispatch node. It's the one we've sold the most, it's the one that we've advertised the most, because these are the ones that earn rewards for service relays. So our recommended setup starts from the internet and having a reverse proxy that handles the connections. It's up to you to have the peer-to-peer port pass through the reverse proxy. Some people prefer to do it naked because the peer-to-peer already uses private key authentication using signed messages, and that's something that Tendermint had since the beginning, and could be considered secure that way. And the connections that happen through that port are bound via configuration, which I'm going to explain in the scalability section. So here you have your reverse proxy, which you can use to do SSL termination and request queuing, and that reverse proxy will connect to the Pocket Core process. This one requires you to set up a staked node account, which is the account that is going to be authorized to participate in sessions and provide service. This one connects via HTTP to your already existing blockchain nodes. It doesn't have to be a naked connection. If you have a load balance set up, if you have any other kind of setup with, I don't know, you want to use indexers and things like that, you can go ahead and do that, as long as you respect the standard RPC interface of that blockchain and not expose some other endpoints that clients coming through the internet won't know about. All the clients, all these requests that you're going to serve through here are going to expect your blockchain nodes to be exposing the standard RPC interface of that node. And last but not least is that we recommend you use secret management to inject the private key of your staked node account into the Pocket Core process. And I'm gonna go over some security recommendations on how to handle this in a later slide. So this node services sessions, relays, and challenges via 3 endpoints. Those 3 endpoints are B1 client relay, B1 client challenge, and B1 client dispatch. Relay and challenge are only gonna be accessible to applications that are within your session. Dispatch, any node can do dispatching, and this one doesn't have a direct economic incentive. However, it is in the incentive of every node in the network to dispatch, because if no one dispatches, or if dispatching becomes too centralized, it becomes a risk of applications not being able to reach their session nodes, and then everyone misses on rewards. So it is in the indirect economic benefit of every node that is servicing to dispatch in the network. Anyone has any questions regarding this node type? Perfect. The second node type that I want to talk about is the seed node, which we were discussing earlier. The seed node shares all the same characteristics in terms of setup, but the seed node doesn't need to connect to any other blockchain nodes to do its work. It's all self-contained within the data that it needs to operate. It's all self-contained within the Pocket blockchain. The job of the seed node is to propagate peers and their addresses. So people can form, other nodes can form connections between themselves whenever they're joining the network with an empty address book, of course. A seed node cannot be a stake node per Tendermint's design and implementation. This is something that we learned through our testnet process, where we were trying to bypass this rule. But later on, we came to the realization, even after diving deeper into the Tendermint code, that this is actually by design that is created that way. And then optionally, your seed nodes can also be dispatchers. So you can dual purpose there and have your seed nodes be dispatchers at the same time by enabling requests on the Pocket RPC port to the following route. The seed node can dual functions by providing seed requests via the TCP port, and then providing dispatch requests via the HTTP endpoint via the Pocket RPC port. But this is totally optional. To be a seed node, all you need to do is expose the peer-to-peer. Any questions regarding seed nodes? Cool, continuing then.
I have a question. Sorry, Luis. Does the seed node need the private key?
The seed node, every node needs a key, yes. Every node that I'm presenting here is gonna need a key. In the case of seed nodes are authenticated into the network, and you need both the address and the IP of that seed node in order to connect to it. This is to make sure that the messages that you're getting are previously authenticated. However, this account doesn't need to be a stake. You can just create a new account using the CLI and set that up. But any node connecting to your seed node is gonna need to know at least your address.
All right, thank you.
Cool. The third node is gonna be the full node. And the reason I want to talk about the full node specifically is because the Pocket network can serve requests to the Pocket blockchain. For example, our block explorer, our wallet, and our dashboard are all gonna use the Pocket network to fetch data from the Pocket blockchain and submit transactions, which means that any service dispatch node can register itself to serve requests for the Pocket network. So the way you do that is by running a full node alongside the rest of your nodes. For example, if you're running Ethereum, you can run alongside it a Pocket full node and connect it via your chains JSON. What we recommend you to do, because no one wants to give free infrastructure, it's that you connect your full node solely through your Pocket service dispatch node. Don't expose it directly into the internet. Just as we recommend not exposing any other of your blockchain nodes. Have it run with its own reverse proxy so you can manage the requests that are incoming to the Pocket core. You can connect them via your chains JSON, and then every request coming from an app that wants to query the Pocket blockchain is gonna be serviced by that full node, just like it will be Ethereum, Tezos, or whatever other blockchain.
Is there a reason not to just loop it back on itself and have it serve serve those requests from its own port. Like if you've got the reverse proxy preventing requests coming in, to your dispatch node from hitting certain APIs, but if you just looped the change.json to point back to localhost port 8081, not going through the dispatch or through the reverse proxy that's going to block those requests, is there a risk to that?
There is not a risk, but as currently constructed, Pocket won't allow for that. It's gonna hang up the connection, and
that's how I'm running right now.
That's how you're running right now by using a reverse proxy. Because we tried direct looping. We tried looping a Pocket core process to itself without going through a reverse proxy.
Right. Yeah. No. Like I've got the reverse proxy in front for when the request comes in. Mm-hmm. But then if it is a request for the testnet network, it's just calling back to itself on 8081. And I know Michael had an issue yesterday, but I've been able to load your Pocket Wallet on a number of occasions and it seems to work.
Well, that is perfect. I would like to know more about your setup because we empirically we tried that. But we tried without the reverse proxy. We tried bridging two processes by themselves, and what we end up discovering again empirically is that the connection will hang. So we actually have that in queue to fully research and if necessary implement that. But if you're able to do it, then I would love to talk to you in order for us to develop a guide.
Yeah, I'd be happy to chat and run through our setup with you soon.
The reason but there's a secondary reason. In terms of infrastructure management, remember that your service dispatch node could be registered to serve other blockchains, which will lead to you serving multiple other applications. So it could become at scale, it could become maybe a little bit problematic. We're separating it, it's gonna be maybe more scalable because you're gonna be able to scale it when you need to. Instead of, because I'm receiving more Pocket specific requests, I need to scale up the service dispatch node, which is maybe not what you wanna do all the time. But if it's totally possible and you're not receiving at a certain scale, it will be totally feasible.
Yeah, the concern I had was that, am I going to enable somebody to send requests using my keys or something?
No, you will not. And that's why I recommend on each setup to limit the block every path except the ones that I list here. Because if you do that, then by no means, no one is going to be able to run a command against that. And our RPC doesn't have any admin debug superpower endpoints. Like all the management happens via CLI and configuration on the server side. But thank you for that, Austin.
Yeah, thank you.
Any other questions? Cool, awesome. So these are our hardware recommendations. I want to talk about these because what I've learned through my experience in running blockchain infrastructure is that hardware recommendations have to be flexible because blockchains are ever-growing systems. And unlike maybe other web scale applications, things happen and evolve, which will evolve the hardware recommendations. The first thing is that, and this one we inherit directly from Tendermint, is that they recommend you use 2 CPUs per process, or 2 vCPUs. A Pocket Core in and out itself can run on single CPU threads and even on half-time CPU threads. But the recommendation that comes from Tendermint is to run on 2 CPUs, which is why we're gonna recommend the same. We recommend running on 4 GB of RAM, not because you're gonna need them at all times, but because we have a mechanism, the mechanism that generates the proofs of service, use something that is called a Merkle sum index tree. And that tree could grow in size very, very large, depending on the amount of requests that you service. And unfortunately, at this point in development, we have to load the tree once in memory in order to be able to produce the proof. The 4 GB recommendation comes from a number, and it's 500 when your node, only your node, not the entire network, only when your node handles 500 million API requests in a single session, in this case, a single hour, you're gonna consume 3.75 gigabytes of RAM in that particular moment. So, which is why we went up with the 4 gigabytes of RAM. Of course, we're gonna keep optimizing, we're gonna keep updating the client to make it as efficient as possible, or maybe use some other optimization techniques that don't have us load the entire tree in memory. But for the moment, that's what we were able to reach with our current optimization side. And then by this, we expect the blockchain, only the blockchain, to grow 154 gigabytes a year, given that we're gonna go in mainnet with 15-minute blocks that are 4 megabytes in size. Of course, not every block is gonna go full, but we wanted to, when estimating maximums, you wanna go with the maximum approach. So that's why we recommend keeping an eye out on the blockchain size. However, we do have a store. We do have other storage needs, but we, in terms of the blockchain size, we deem them not negligible, but they are gonna be covered as long as you follow this trend of having one. If you plan yearly, for example, having 154 gigabytes for each Pocket instance, and then for example, the mempool and it's all of that is gonna be all the things that are configured to be stored in disk by Tendermint, which is the majority of those. Is configurable via the config JSON, which we expose transparently. So we're gonna, and I think I didn't link them. When I send the slides at the end, I'm gonna add the slides with a few links that I think are interesting, at least from the Tendermint side. And because we didn't do any modifications to those, they are gonna apply right away. Any questions about this? Cool. So let's talk a little bit about the scalability considerations. In our load testing, we came to the conclusion that we were trying to make Pocket Core run with any file descriptor setup that you will throw at it, because we wanted every request to be as fast as possible, liberating a connection right there. But the reality of the situation is that Tendermint in and of itself allows you to configure some persistent file descriptors, and then bounding the amount of relays that you can do at the configuration level seemed to us a little bit too restrictive, which is why we recommend everyone on the reverse proxy to do rate limiting or request queuing, and use the formula that I'm gonna describe below to calculate the amount of file descriptors that you need, specifically in the ulimit SN command, which is a particular type of file descriptor. Of course, this varies per OS, but it should behave the same on every asterisk Nix-like environment that you run Pocket Core on, which is, I believe is gonna be the majority, unless someone is running on Mac server. Regarding Windows, in case someone wants to run on Windows server, that is something that we had to delay on our roadmap to do Windows testing and see everything in terms of the configuration. So we don't actually recommend right now running Pocket Core on Windows until we release the documentation for it. So the way the formula works is as follows. What you're trying to do is determine how much in the U limit you need. It needs to be greater than or equal to satisfy your Pocket Core's requirements. So the first thing is the max number of inbound peers. That means all the peers that are connected to you because they for example, a seed node gave your address and IP to them, and they're gonna try and establish a connection to you, which is different from the max number of outbound peers, which are the peers that you have in your address book and you're attempting a connection to. This creates a circular kind of topology where both connections are treated separately. So the next thing that you need to have is the number of gRPC max open connections. These are the connections that happen over via WebSockets between the Pocket Core application and the Tendermint node, which also is different from the max open connections, which is the ones that happen via HTTP to the same Tendermint RPC. Tendermint exposes two things. Exposes an ABCIE interface through which it alerts the Pocket Core node everything that is happening on the blockchain side. And it also exposes HTTP RPC, which is governed by the max open connections parameter, which is the one that when the application needs to request data from Tendermint, that's the one it uses. So these two are two separate sets of connections. The next variable, which is not bound anywhere in the config JSON, it's the desired amount of concurrent Pocket RPC connections. This is gonna be purely on how you want to scale your node. You wanna, for example, one template that we're gonna prepare users for is to be able to calculate these around handling 10,000 concurrent connections via the Pocket RPC port. And we're gonna limit this via using the request queuing in the reverse proxy. So you add that amount in there plus 100, which is a constant number of wall, DB, and other open files that it's gonna be always constant. So if you sum all these variables up, which the first 4 are available as named in this slide in the config JSON, and this based on the setup that you're gonna be configured, plus the constant files constant, you're gonna get your ulimit SN that you need to have set up for the Pocket Core process to run. Does anyone has any questions regarding this? So moving forward, last but not least, never least, are the security considerations for Pocket Core. Right now, as per version RC 0.4, there are 2 ways to input your private key. One is more known because that's the one we have in the documentation. And the first one, the file input, is very recent and we still haven't documented it. But we're in process of doing so, which is why I wanted to share it with you. You can input directly these 2 files, node key and private val key, into your Pockets data directory with the private key. This is a design that we had to inherit from Tendermint because Tendermint uses these files to read the node's identity. And the second method is you can automate the creation of these files by using our CLI and inputting the private key by importing your account first and then setting it as the validator with the set validator method. Some of you and some other participants in the community have expressed concern about the automation of these commands because we always prompt for a passphrase. And we have to because of security, which leads people to have to use expect, which is not the most desired scripting. So that's why we exposed the naked functionality of inputting the files yourself. And as long as you put these files in the root of your data directory, when you run Pocket Start, you shouldn't be prompted to input anything else. But our recommendation, as always, is gonna be to secure these files via OS level user permissions. What does this mean? This means that the user that is running Pocket Core in your setup should be the one that has access to reading these files. You don't even need to give it write permissions. It just needs to read these two files. So right now, that's for us the most secure way that you can go about setting up your Pocket Core now. Of course, you have to think about all the layers that you have to breach in order to get to these files in the first place, which I'm pretty sure all of you have your own security measures, your own security standards, and we will definitely do more research into more straightforward ways in which we can secure these setups, but that's gonna have to be in a future update. For now, we ask each one of you and everyone running a Pocket node to keep these files secure at the OS level so you can avoid tampering and any other sorts of attacks. You could even have, in some setups, you could have automated deletion of these files as long as you have them backed up, of course. Automated deletion of these files in case of detected intrusion into the system. That way the attacker, even if they get into the blockchain, they're never gonna get an unencrypted version of your private key because the only place where that exists is these two JSON files. Whenever you import here, that file is gonna be, that private key is gonna be kept in our keybase, which stores it encrypted. And so as long as they don't know the passphrase, they're not gonna be able to unencrypt. And then the set validator is just an interface to create these two files. So if you delete the two JSON files, you should be automatically protected. Any questions regarding this? One last thing that I wanna add is that in the slides that I'm gonna send, I'm gonna include a slide before the last one, where I'm gonna include a few links, especially to the Tendermint configuration, so you guys can learn more about that. But regarding that, the scalability formula should be the one that we have to deal with more directly. But that's it, guys. Thank you very much for coming. So I'll share the slides as soon as possible. And if you guys have any questions or comments, always feel free to reach out to me via email or via the Discord server where me or anyone else from the team is gonna be able to help you out.
Yeah, I guess we can take this time if you guys have questions or any other extra questions or anything.
I know you have a health check endpoint on, I think it's on the Tendermint RPC port.
That is correct.
What does that check?
It actually just checks your nodes. It's the status endpoint, right? The one that you're talking about. So the status endpoint, all it checks.
There's actually one called health.
The health endpoint, yeah. So we use a status because the status says the block number and our node's identity and all that. But health is not that useful, to be honest. We never even considered it as useful.
Yeah, right now, I've got my endpoints to point to that to determine whether or not a service is healthy. But I've gotten the impression that I can be in a pretty bad spot and that still be returning 200 status code.
Correct. One of our, just so you know, like in our roadmap, post mainnet, our roadmap so far has focused a lot on implementing the business rules and the protocol rules, so the network can run. But another very important aspect that we want to focus on is making node runners' lives as easy as possible by exposing metrics, analytics, and more. However, I do want to say that in terms of analytics about the network per se, Tendermint exposes a fourth port that we have disabled by default, and we wanted to share more about that with you at a later date. But just as a preview, is that they offer a Prometheus endpoint that you can leverage to get data from the network. And they have some interesting queries that I'm gonna share in one of those links. But right now we don't do any exposition through Pocket of that. So to be 100% honest, I don't know how useful that's gonna be to your node operation. Everything that we deem useful to a node operation is what we've exposed so far.
Okay, yeah, so in particular, like I had a bunch of nodes, all of the nodes that I'm running yesterday afternoon got jailed. And as far as they were concerned, they were still healthy.
That is correct, because what you could consider health at the infrastructure level is not the same as health in the consensus level.
Right.
Which is why we didn't want to like try to cook up a health-based solution that marries the two. But we know that that's the most important thing, because a healthy alarm system, and we had to construct one like kind of manually, where it checks the network to see if the node's jailed, and then checks the network health via or other mechanisms. It's not the most, let's say, user-friendly from a node operational standpoint.
At the very least, though, I'd like, and I mean, you know, I can figure this out, but I would like alarms to be going off if my nodes have been jailed. And
yeah, that is definitely fair. That is definitely fair. But one thing that I want to say about the whole jail situation is that the last update we made, so this last Genesis, and we were tricky about this. We didn't tell you guys or anyone in the community because we wanted to see like a chaos unicorn kind of way where our Genesis, our parameters of the network currently are configured very similarly to what we expect them to be on mainnet. And it was intended so in order for us to figure out the kind of issues. Because right now, if your node misses one block in the production, it's gonna be jailed. And we have noticed that this might be too extreme in terms of configuration. And thanks to that, we're looking at loosening up that requirement to avoid this situation. There is also the fact that we changed how our timeouts for block times happen. And we're gonna be launching new revised guidelines in how to adjust the timeout commits, so your node should be in no risk of being jailed, even if you're just applying an update. Like our own nodes got jailed because we applied updates right when the timeout was happening for the block, and that's extremely inconvenient from an operational standpoint. So we're looking at enhancing that situation, and probably will in our upcoming release.
Could you share with us the specific metric on which a node is jailed? For example, he missed one block or 6 blocks. what happens if the non-native node isn't available when he has to respond to requests, that kind of things. That seems a bit.
Yeah, I can definitely explain that, and maybe I should do a second session to go into the specific of the consensus part only. The reasons are twofold. The first reason a node can get jailed is for missing blocks, and currently the amount of blocks that they can miss, it's a parameter that is configured in the network. When we release our dashboard, you're gonna be able to see some of these parameters, but we're also looking to expose all of them because the list kept growing with time. We're gonna expose all of them and a way on which you can query them and a way in which you can interpret each one of them. But right now there is a parameter in the network that specifies how many blocks have to pass for a node to get jailed. Right now it's 1 as in testnet as currently set up, but as I just mentioned, we might have to loosen that up for the mainnet release in order to avoid these mass jailings that have been happening on testnet. The second reason, sorry for leaving at that. The second reason is something that is very of the way Tendermint handles consensus, and it's called a double sign. That means that the same node with the same identity signs the block 2 times in order to try to get double rewards. That's the worst thing, one of the worst things at the consensus level that can happen, and you're gonna get severely slashed if you try to double sign a block. In terms of the non-native chain being offline or offline, there is no direct punishment for that because cryptographically we can't prove that your non-native chain was online or offline. However, you're gonna miss out on that relay because what Pocket Core is gonna do is gonna respond with a refuse to connect or whatever else, and then you're gonna sign that back and you're gonna be like, okay, this is an error response, and you're not gonna be rewarded for that relay. So you're missing out on rewards is the kind of punishment that's gonna happen in that case. Guys, I thank you very much for your time. I know we're over time. I'm gonna be sending these slides, and I'm gonna include that additional slide with some links that you could check out. And also keep on the lookout that we're gonna be upgrading our developer portal very soon with multiple new additions regarding these topics that were discussed right here, which are currently not online in the developer portal.
Thanks, everyone. Thank you for coming. Much appreciated.
Thank you very much.
Thank you.
Congrats, Luis.
Yes.
Thank you. Thank you.